Now,
Got
Ooh,
it. That sounds like the second. We are underway again, ladies and gentlemen. Welcome aboard. We're doing it again in the pivotal new year, 2025, everybody. Brain trust from our 70 years old Astrophysics Telescope Club, the Santa Barbara Astronomical Unit, convenes on the Zoom screen once a week, this time for our 203rd episode of the SBAU Astro Hour. It covers January 13th through the 19th of the new year. We're a fun club, everybody. We meet at the Santa Barbara Museum of Natural History, which sponsors us. Just $20 a year to join SBAU. When it comes to outreach, I got to tell you, we are everywhere. I'm your proud host, Ronnie Herron, Vice President. On behalf of the rest of the board, I'll introduce you to here in a minute. Invite you to come explore the cosmos, learn with me and my buddies. Don't ever drop this program on your foot, or you'll look like a duck. It's a very heavy vlog, I've been told. All right, let's talk about Mars reaching the milestone. I think today we'll ask the guys, what about the rest of the planets? That full moon up there. Wow. Orion was a popular sight attraction for our lenses at Saturday Night Star Party over the weekend. Where is it now, huh? In the sky for winter. Going to give you a topographic view of our planet. Got some surprises in store. And can you say oblate spheroid, boys and girls? What's a geoid surface, for crying out loud? And what the heck are spherical harmonics? Truth be told, Earth has a battered history. The Juno probe discovers a new large eruption on Jupiter's Io moon. Plus, we have Jerry's forwarded silly science stuff. Let's meet Jerry and the gang. Jerry Wilson, beloved
good
professor,
morning.
president for the 6th or 7th year in a row. I keep losing track. Back in the late, yeah, okay, you too. He's married to the very lovely Pat Forgy, also married to a Pat McPartland is Chuck McPartland, our outreach guy in front of the Ukraine flag. His wife is the merchandise manager and a very good treasurer for the club. We'll take everybody in order of joining us on screen. Tom Whittemore used to be out at Westmont, and he was an incredible science instructor. We'll be there this Friday night, incidentally. Are you going to be hosting things, Tom, for the Friday night?
It turns out I will not be able to make Friday, Chuck.
Okay.
I won't be able to do it. We have something else going on. Okay.
But one of our past speakers, Jennifer Ito, will be there in charge, won't she?
Yeah, she should be there to open up the scope.
Okay, good.
Okay. And how's Maureen, your wife?
Fine. Good. Yeah.
Fantastic. Bruce Murdoch is on screen. He's married to Bonnie. Hiya, Bruce.
I'm doing great.
Bonnie's recovering. You were telling me about it Saturday night.
Yeah.
Longtime supporter, telescope enthusiast, and man, a busy man. If you are you able to do anything with your Santa Barbara Theater Organ Society as president?
I'll be down there tomorrow morning at 9 o'clock to be doing repairs.
Okay, it's not a public event. We're not invited to come along unless
we normally have an open console once a month, but when they did the Nutcracker, when they moved the organ console, they damaged things, and we're still repairing the damage.
Why would they have to move it? It's under the stage, isn't it?
It's in the orchestra pit.
It is? I thought it came up out of the stage.
Right, but that whole about 12 feet of the stage is false. They're wooden panels. They come out.
Oh my God, even your stages are false these days. Tim Crawford, how are you, Mr. Expert?
All communication with the chambers is electrical.
Okay.
And it gets the console gets pushed off backstage. And then they start using, they use the lift to carry stuff up and down. And they, it's a full orchestra that's accompanying the Nutcracker.
Next time you have an old silent movie and some real excitement, invite us all. Send out an email. I'll go. We just don't know your agenda. Tim Crawford is married to Karen, longtime SBAU member. Let's go to the cartoons and silly stuff, and then I'm going to ask Chuck if I can remember to update us on some outreach things like Hollister Ranch. I heard you talking about. Is that open?
That's not exactly for the public, so.
Oh, it's not. All right. Well, let's talk. Let's go to the forwarded silly science cartoons and some heavy stuff. These are the
I like this one.
The two landing extraterrestrials discover one of our Marburg porta potties, and one of them says, speaking in English for some reason, Our sources show this is a heavily trafficked building of importance with ample storage. Must be their nation's capital. Take me to your porta
These-
potty.
These days, that's close to true coming up.
Apparently extraterrestrials don't do number 1 or 2. Oh my God, there is a hominid. That's how they looked, exactly like Keith Richard of the Rolling Stones, way back at the beginning. He's been a Neanderthal.
This was posted under the title of Reconstruction of Earliest Known Hominid.
Earliest hominid, Keith Richard of the Stones.
For some reason, the internet and everybody's picking on Keith Richard for looking old. He's about the same age I am, so.
Oh, that's old.
Yeah, I know, but I guess he has a pretty thick skin. He's a wonderful musician.
I met the band early in their career in 1964 backstage at the Bakersfield Civic Auditorium.
Uh-huh.
Here's a repeat of a former one that
Yes.
we can't get enough of, Quantum Meowcanics.
Meowcanics. And these are all the famous jokes about.
Schrodinger's cat is he's either dead or alive.
Yeah, we can't see in there.
We'll never
This
know.
is a relativistic cat. This is a positive cat, and this is a anti-cat. So
Okay.
if they meet, they annihilate.
Oh.
This is the De Broglie cat. That's a De Broglie wave. And the joke,
Okay.
when I was an undergraduate in quantum was De Broglie waves, wave back. So that's an alternate method there were several methods, mathematical methods to quantum mechanics back in the day. There was wave mechanics, which is what's taught in Introduction to Quantum. But there was also matrix mechanics. I forget the guy that championed that. And it works fine, but the intermediate steps have no obvious physical interpretation. So it was not used. It's not used very much. This is
it more accurate or something?
What's that?
Is it more accurate?
No, it's not any more accurate or less accurate. It's just an alternate way of doing it. Like classical mechanics, you can do mechanics problems by using forces a la Newton, or you can do it using Lagrange's, or you can do it using energy. They're all equivalent things. They use different mathematics to describe similar things. Forces were more intuitive back in the 1600s, so that was what everybody used at first.
1600s? We didn't get to quantum till the 20th century.
Oh, no, that's quantum mechanics developed in the 20s and 30s in the 20th century. Classical mechanics was defined by Newton in 1660.
Well, I noticed the one on the lower left, the Heisenberg cat, is disentangled.
Oh, yeah, we'll get to those.
I know.
This is the Fermi cat. And what this shows is that, for example, electrons in an atom, they have the uncertainty principle, not the uncertainty exclusion principle, that no two cats can occupy the same state. So there'd be 4 orbitals around an atom nucleus, but the cats can't all go in one. But if it's a Bose particle, a boson, then all the cats can fit in the ground state, for example. And when you have all the bosons in the ground state, this is superfluidity. You get all those weird properties, very quantum. And you get, if they're charged, you get superconductivity. The uncertainty principle applies to a lot of variables, that is conjugate variables, for example, frequency and time alternate with each other. So, for example, in the Heisenberg uncertainty principle, you can't know position and momentum, but there's other variables that also have an uncertainty principle. And in the state of a Bose condensate, that is phase and number. So when everything goes down to the lowest state,
ground state,
yes, then the number of them disappears. These cats will all act like a collective one cat because they're all in phase. So you know the phase perfectly. So you can know that you can't know the number of them at all. So it's an uncertainty principle there too, and that's what that's trying to illustrate.
Wow.
There's an interesting thing about, Fermi's the exclusion principle. If you know the energy of the electron and the it has to be an integral number of wavelengths to go around the orbit.
Yes,
Even
exactly.
through. And if it isn't, it can't happen.
Well, as you squeeze it into a tighter and tighter potential, like it moves toward the atom's core, then the wavelength overlaps itself out of phase. And so it starts canceling itself out. And that's why the wave function simply disappears.
Mm-hmm.
It's the first question that Ron asked when we started this. Why doesn't the electron just fall into the proton in a hydrogen atom? Because they both have opposite charge and they attract each other. And that's because the electron's wave function overlaps itself and it eliminates itself through being out of phase.
Did old man Albert ever embrace this before he died?
No,
He never did.
no.
All right, here are a couple of bubblehead aliens talking and looking up at the vastness. This is the void, Quasimodo. We call it void, not because we know it is empty, but because we don't know what the heck it is full of.
Right.
But it's right next to a giant galaxy called Null. And they're
Oh.
null and void. Never mind, shut up.
Okay. So it turns out that Einstein's equations in general relativity predict attractive gravity, but in free space away from mass, it predicts repulsive gravity. And there's a school of thought evolving around that may be dark energy, just that repulsive side of Einstein's equations.
Pushing things out?
Yes.
Would that be the explanation for space itself expanding? The same thing as dark energy?
That's what Jerry just said. Yes.
Yeah.
Oh, okay. Well, I got chastised by you one night when I said it was opposite dark matter. It seems to be. It does everything exactly the other way, wouldn't you think?
It's not.
Okay. Well, I'll take your word for it.
Okay.
It's fascinating stuff. So we're watching the night sky and there's something happened. Oh, I wanted to ask you, are we done? Oh, yeah. Before we do this, Chuck, you're going to watch an occultation of our red planet neighbor?
Just eyeball and binoculars, yeah. But tonight, as the moon rises, you need a good horizon because it's going to start when the moon's only 7 degrees up.
Mhm.
But
Okay.
it's going to pass over Mars, and it'll block Mars out at around 5:51 tonight, and then the moon moves through its own width in about an hour. So at 6:46, Mars will pop back out at the top of the moon, so you can watch the motion of the moon.
Is it on this map, Jerry?
This map is not tonight. This
Oh.
map is January 3rd, 10 days ago. And the reason I put it up is because someone posted a very nice photograph of Venus and the moon. And I saw the same conjunction as I was walking to our club meeting 10 days ago on the 3rd. And so it's just a pretty picture. But this is the sky map on the 3rd with the moon and Venus above the western horizon just before it sets about 6:30 or 6:35. And the moon won't be there, of course, tonight, but Venus will be there. All the rest of the stuff is accurate. And this is a picture that someone posted of Venus and the moon close together on January 3rd.
Venus has got all the brightness in this picture.
Yeah, what do you see? Is it washed out or unwashed out?
It's pretty washed out.
Oh, when it's too black or something?
No,
it's
too white.
Overexposed, yeah.
Okay. Okay.
You couldn't see the phase of Venus.
I guess
I saw it
so.
Saturday night. It was bright. I didn't know it got that high. I haven't been watching lately. I have this feeling that it's on the ecliptic, and so is our own. What do you call it? The stability of the Earth. Is our equator about level with the ecliptic of the sun? No. It isn't, is it? Not at all.
23 degrees.
23 degrees.
Oh,
so can you see this picture okay?
We're still not seeing any phase on Venus. It looks pretty much
like
no,
there's no phase on Venus. Venus is just overexposed.
Okay, yeah. But you can see the moon better on this one.
Yes,
Mm.
this is the proximity of the two.
Well, there's a lot of spikes on Venus.
Well, that's just diffraction spikes with the optics.
Right, that's
Yeah,
all.
but
the
but
camera optics.
what what optics do
It's
that?
a refractor, it looks like,
Yeah,
That's what I'm wondering.
or a telephoto lens.
Yeah.
it's got a lot of these spikes on camera lenses is due to dust on the lens itself.
Okay.
They need to clean it. Now this one you don't need to clean your glasses off. These are blurry. But this is the same side of Ganymede taken by Uwe Milling in Germany. Good art. And this is the picture that he took with his 400 millimeter aperture Cassegrain of Ganymede. And this is a Ganymede, same phase of Ganymede by the Hubble in 1996.
It looks like they're inverse.
Pardon?
Looks like they're inverse. Where the one on the left is white, the one on the right is black.
Well, rotate the one on the right 90 degrees left, and it should be right.
Wow. Imagine what it would look like if the
Yeah, this stuff up here and this link, I take that to be this stuff and this link here.
Oh, okay.
So, and then there's a big whitish area down here. It's roughly the same phase, the detail difference, but for an amateur, this is pretty damn good.
Would
And
that be Jupiter's biggest moon?
It's the biggest
Yes.
moon in the solar system.
Oh, okay. So it's bigger than
he has taken 27,000 frames in a video, and using auto stackert, he has asked the software to take the sharpest 10% of those 27,000 frames. So 2,700 frames, and they are stacked to give this image.
Wow. And that's a moon in a distant
Yeah,
planet. Jeez.
it's just a little dot in my scope.
Well, imagine what Webb could take. They aim the JWST.
I don't know. Yeah, the Webb has a bigger optics. It will be sharper too. So we are going to have tonight. We are going to have a occultation of Mars, and these are the times posted on the magazine Astronomy for the different on the East Coast, the Kansas City Central Standard Time, Denver for Mountain Standard Time, and highlighted the West Coast for us. We'll slide in front of Mars some 10 minutes before 6 p.m. Pacific Standard Times. And you can get a specific one located not just for the center of Pacific Standard Times, but down to your actual city if you go to the International Occultation Timing Association's webpage.
And your city's there.
Yes, and your city.
Well, Santa Barbara there, I hope.
Yeah, they usually list us. Now this is 6:35 tonight
That doesn't jive.
with the statement that I made.
Yeah, Mars will be behind the moon at that time.
This is what my planetarium software claims for my backyard.
Yeah, that's not right.
Okay, but it's
You have to
close.
move your backyard.
What's that?
You got to move, Jerry.
So this is this just a few minutes different, and it's completely obscured by this. So
That'll happen at 5:51 for us. So
What's that black dot that's up and to the right?
that I explored that because it really stands out. That's a planetary nebula.
Oh,
For some reason, it is highlighting itself.
Really?
But
It's Tim's favorite.
Shows up black in a black
Yeah.
sky. How in the world?
it's clown phase.
5:50 p.m., which is in line with your statement, is for the center line of Pacific Standard Time, and we're not on the center line. So I'm assuming that's the difference we see, is the few minutes difference between the picture my planetarium software gave us and the center line of the Pacific Standard Time. So where is okay.
Well, I guarantee you, if you go out at that 6:30 time and you look, you won't be seeing Mars.
Well, it'd be behind the moon.
Yeah.
Yeah. So this is just that was the time. I think that was the time it just popped out from behind it.
No, it's going to pop out on the upper edge at 6:46.
So that's when it's going to get absorbed. Okay. Well, we'll have to talk about it again next week.
Well,
so this is the area around the Cetus, and there's in the talking points we have some information about Cetus, and the variable star Mira is discussed there. Mira goes between about 6th magnitude and 11th magnitude, if I recall correctly. No, it's brighter than that. Let's see what the thing is. So it's not there right now. This is above the southern horizon with, and it has it goes between 2nd magnitude and 10th magnitude, wider than I thought. It's a red giant star, and if you look at the constellation Cetus these nights, you will find that it's not there.
It won't be there because it's so dim?
Yeah, too dim.
Yeah.
About 6 months from now, about 6 months from now, it'll be back to what the star chart shows. Now, on January 15th, our moon is in opposition, which means it lines up with the sun.
Wait. You must mean Mars.
Oh, yes, Mars is in opposition, yes.
Meaning we're on both sides of the
Yeah,
same.
our moon is in opposition when it's full.
Which is tonight or today.
But Mars is in opposition at this point, and this is midnight on January 14th, but on the 15th, Mars will be in opposition.
On behalf of the more simple-minded folks like myself who are watching this, gentlemen, are most of the big planets out there on the same side of the sun right now?
Loosely, I guess.
Yeah, they're in the evening sky.
Yeah.
No, but on the same side. There's
yes, they're in the evening sky.
Yeah.
Oh, okay.
If you stay up all night, you can see all the planets. Now, this is a set of pictures put together. This wasn't in the handout, but this was put together by Robert Cazevac in France. And these are the oppositions of 2020, 2022, and 2025. Obviously, this one hasn't happened yet. And it shows the relative size in seconds of an arc. This is very close to as big as Mars ever gets at opposition. And 22 seconds. It's been in the 50s. I saw when it was 25 seconds across, and you could readily see details on it. I was looking through the Griffith Park 12-inch refractor at that time. The in 2022, let's see, this features there and there and there. So it's roughly the same side. This features there, this features there. Yeah, this feature seems to be up. Don't understand that. But this is how big it will be Wednesday night in January 2025 in relative size. It's still big enough to see a lot of features on it.
Need good seeing, and we're not having that lately with all these jet streams.
Yeah, that's true.
Yeah, right. And they come in quickly.
But no Southern California fire smoke has drifted over, as it seems.
We had a bunch Saturday night. It was fairly
did?
smoky. Yeah.
Wouldn't you be able to smell it? My breathing was fine.
Well, you could sure see it if you looked out toward the ocean.
Yeah. Yeah, there was a brown haze that we saw,
Brown, yeah.
but we didn't smell anything either.
No, it's in the upper atmosphere.
Yeah,
Jet
probably.
stream.
Can I ask a real quick question, a side thing about Mars?
Yes.
Well, have they predicted, does science know what's going to happen to its two little dinky moons? One's going away and one's going to crash in the future?
Phobos is definitely going to crash into Mars in about 3 billion years.
Well, could it make a ring around Mars like Saturn, a mini ring? I've heard that that's possible.
Not a whole lot of material in it, but yeah, potentially.
Yeah, find out what the Roche limit is for it.
It's going to depend on how strongly held together the moon is.
I'll let you know.
It could crash as a solid object and make a big skid mark.
If you look at pictures of it, it looks like it's pretty thickly covered in dust. So it's probably a rubble pile-ish type thing.
Okay.
But Mars
So this is a picture from January 3rd, taken by Damian Peach. And he uses a 14.4 inch celestron. What's that?
He uses a 14 inch, a C14. He's saying the diameter of Mars here is 14.4.
Okay. Yes, you're right. He uses a 14 inch. So anyway, it's an excellent picture. And it shows the features that you're likely to see if you look at it. You're not going to see any canals. You're going to see these albedo features, which are due to, they change their shape and color due to sand shifting on rock.
Oh, I didn't know that.
But how come we can't see Deimos and Phobos in any pictures? Are they that small?
7 miles and 13 miles.
Say again, Chuck? I didn't hear that.
7 miles and 13 miles across.
So they're more or less asteroids that have been captured, aren't they?
Well, they seem to be pieces of Mars that were blasted off when the Hellas Basin was formed, is the latest version of how they ended up there.
Be damned. So you'll never see them really in pictures. They're just too small.
Well, there are satellite, spacecraft photos of them.
Yeah, you got to get close-ups.
Yeah.
I've seen Earth-based photographs of the dots of light near Mars. And remember, they were discovered visually around Mars, so they can be seen from Earth.
Yeah.
Well, I'll just bet you your gas giants, the other four out there, have millions of little chuckers like that you never see.
Well, they do. Saturn does in the rings.
Yeah. Billions.
Really? They're rocks the size of Deimos and Phobos and Saturn's rings. All right.
And Jupiter has faint rings also. So I don't know about millions, but they certainly have hundreds of moons or 100 moons.
Interesting.
146 officially for Saturn and 95 for Jupiter.
Used to be the other way around, didn't it? Jupiter had the most moons.
Yeah, way back.
Amazing.
Now, this is a photo also by Damian Peach, where he used a filter to highlight the clouds creeping around the limb of Mars. These are high altitude water clouds. Yes, cirrus. He calls it a B filter. I'm not familiar with that notation, so.
Blue?
Could be. I know I label my filters 1, 2, 3, 4, and 5. And it's convenient in the software, but it confuses me later because I never remember which one's which.
But the reason it's known as the red planet is what? Iron?
Yes.
Iron oxide, yeah.
Iron oxide.
Now this is an albedo feature on Mars called Sinus Meridiani, which is this region here. Looks like a paw reaching out with some claws down. It dominates one side of the planet and is on there on the equator. It was named by astronomer Camille Flammarion in the late 1870s. that feature, that's interesting. Software's not letting me go past that one. I'm going to have to stop share and go back to the other way to share.
That's also where they defined the zero longitude.
Yes.
Hmm.
So that's why you have meridian in there. Oh, that's all blown out now.
Ugh.
Looks like
Okay.
your Antares close up that you sent us.
Next week, I'm going to switch completely to photo,
Another software, huh?
another software. Yes, thanks.
Bless your heart.
Decided is good. So
Never forget good old what's his name, right?
Yeah.
is this good?
That's decent.
It's beautiful.
Okay. This is the plateau and the geographic structure in Sinus Meridiani. It's a bunch of layered stuff. This is hard, and apparently this has been blown away by wind. But it's one of the, this is photograph taken by the high-rise orbiter. And then this is the region where one of the Opportunity landed and explored Sinus Meridiani. It's apparently a flat and mostly rock-free plain. Hence, it was chosen as the landing site for the Opportunity. And this is
Blueberries.
blueberries. This is called Berry Bowl. Was one of the first sightings of the blueberries. You can see where it's whipped around and scoured the surface trying to look for how strong it is. I guess it was before they could really drill into the surface like they can with the new ones. These are hematite and they form in water.
Ooh,
And this is a close-up of those blueberries on a rocky outcrop in Eagle Crater.
they're certainly not colored blue, but they're the shape of blueberries.
They're kind of bluish in
Yeah.
the pictures.
And
How come this picture originally came in looking pretty good, then it blew out?
oh, this one?
Yeah.
Yeah.
Okay. Well,
They all the blown out ones do that. They initially show decent contrast and then they blow out. So
Okay.
there's something that's messing with your picture for display, which may be
Yeah.
zoom or maybe something else.
Okay.
No, the same process on Earth that rounds out rocks over years of tumbling water was on Mars for a long time. It's amazing. I've heard blueberries are very good for you too.
This better?
Yeah.
Yeah.
Okay. Whoops. Okay,
Actually,
so
it looks like
these are blueberries and on the rock, and I don't know if the little teeny grains are blueberries too, but I suspect that's just blown in sand.
also looks like viruses under a microscope.
Yeah.
It does. So there's 3 of them in mitosis.
Yeah.
So now we had sort of touched on something like this earlier. And so I said I'd have a display on it. And so I researched the shape of the Earth for good graphics. This is something we had to deal with a lot in designing our spacecrafts. When I was working at Santa Barbara Research Center, when you propose a spacecraft, even an instrument on the spacecraft, you have to put that spacecraft into a software program, which NASA requires, that handles the Earth orbit in a very precise way and shows the scanning and what you're likely to see and everything. And it's how NASA evaluates your proposal once you get a complete design in there before you get completely paid off in your funding. And I forget the name of that software, but the core software is about $125,000 for one copy of it. And I had that on my laptop or desktop in the company. And you can get add-ons for like the moon and Mars and planets that they have accurate gravitational fields for. And that maps the geode, as they're calling, which we'll get to that. But this is basically the shape of the Earth, and you can see that it's redder around the equator and bluer toward the top. So that is basically height from an idealized sphere. And that is, the red stuff is higher away from the center of the Earth, and the blue stuff is a little bit closer. It's only by about, this is 63, 61.
20 kilometers.
Yeah, 20 kilometers. So it's not a lot, but these things do matter for spacecraft. The types of things the orbit. So this is the rough shape of the Earth. The simplest shape is that it's an oblate spheroid, as opposed to a prolate spheroid, which is basically football shape stretched out. But we're flattened, as most planets are. Jupiter is noticeably flattened that way. And if you look at it within your mind, that you're not going to see it as a circle, perfect circle, you can actually see the oblateness of the circle in your scope. And if you go to make drawings of it, you have to prepare an ellipse to draw the Jupiter in, because it won't fit in if you're accurate, it won't fit in a circle.
Something that big going 10 hours.
Yeah. Now, this is an interesting thing that's drawn to scale that I found on Wikipedia. It's a scale of the oblateness of the reference ellipsoid. The outer edge of the dark blue line is an ellipse. So this is an ellipse, the dark blue line, with the same eccentricity as that of Earth. The red curve represents the Kármán line. That is, this is the arbitrary definition of where outer space begins. It's 60 miles up or 100 kilometers up. And if you go above that line, you're in space. If you're below that line, you're just very high up in the atmosphere. And so then the orange band up here is the altitude range of the ISS. So this is as low as the ISS gets on the inner side, and this is as high. And that's about 250 miles. So this is about 60 miles. This is about 250 miles up. But it doesn't go over the poles. It just stays at this altitude.
Aren't they talking about deorbiting the space station?
Yep.
Yes. 2030 is when they're planning to do it. I don't know if they're going to deorbit all of it or part of it.
I think it's all of it to Point Nemo.
I wonder if those astronauts will be on board still.
They're supposed to come back, I think, next month.
Including those two that got marooned up there a year ago.
Yeah.
Well, I heard Neil deGrasse say that the mountains in the northern Andes of South America are actually higher than Everest.
Yeah, that's
the center of the Earth.
Where you measure the heights from the Earth's center or from mean sea level, you get different altitudes.
Oh, that's interesting.
Yeah, Hawaii is one of the tallest mountains on the Earth.
Is it really?
Measured from the seafloor.
Yeah.
Well, I've even heard that Earth was pear-shaped. Have you ever heard that? That means bottom out, southern hemisphere. Is that possible?
We're getting to that.
Oh, okay. Sorry about that.
Okay. So anyway,
There you go.
This is what the Earth's gravitational field would have you think the Earth is like. This is obviously exaggerated. So the green here is the mean. The red is that's so hard to read.
I mean, these are different strengths of gravity we're looking at?
Yes, essentially it is. It's called the geoid.
Well, just tell us that blue at the top, is that less gravity or more? And then the other end would be the opposite, wouldn't it?
The red is higher altitude in meters, according to that table up here. This goes from, that's what I was trying to get a read on. Right. It's in units of about 20 meters. So this is 20, this is about 80, and this is about minus 80. So this is below
the Indian Ocean.
Yeah. The one that's blue, just below the dark blue, is 88 meters.
Yeah, there. Yeah. Oh, you can read it? Yeah.
I used a magnifying glass on the screen.
Okay, thank you.
See the
so this is what the Earth would look like if you were measuring its gravitational field as you flew over it.
Wow. Well, then why is that?
That's what this program does for us when we work our trajectories out and what the satellite is going to do. I forgot the name of that program. I used it every day.
And some of this, Ron, you just said, why is it like that? It's like why you have the moon tidally locked to us and you have the mares. It's humpiness in the inner Earth.
Right. And the moon has a humpiness of its gravitational field too, because under the mare on the near side, there are what's called mascons, which are the bodies of dense bodies that hit the moon, and they're still buried there. And a lot of that is due to parts of Theia buried here. As you recall, we have a violent history to our planet. So there are still blobs inside the Earth that are believed to be remnants of Theia down above the core. And these are denser. They are like mascons on the moon, but they give us irregular, non-spherically symmetric gravitational field.
Theia was a body about the size of our moon that crashed into us, right?
About the size of Mars.
Right.
Size of Mars. Mars is that much smaller than us?
Half the radius.
Okay.
1/10 the mass.
Yeah.
Okay.
Now this is a cut through the Earth showing the ellipsoidal or the actual shape of the Earth, not just the gravitational field, but the shape of the Earth in terms of slicing through the North Pole and the South Pole. The equator is here, and you see that it's got a rise up here at the North Pole, and it's got a little bulge out here and a little bulge out here. And at the South Pole, it's not as far, it's pulled in. So this is the actual shape of the Earth instead of an ellipsoid. This is the pear shape for our Earth.
The red.
The red is, yeah. The black is the ideal ellipse in the ellipsoid that we showed earlier.
Well, there's a lot of mass at the South Pole. It's an actual continent, whereas there is no continent at the North Pole.
Yes, it turns out though that continents are lightweight materials on the Earth. They float on the rest of the materials because granite is the primary constituent of continents, and it's not a very dense rock, not like whatever comes out of a volcano.
Basalt lava, yeah.
Yeah, basalt, that's what I was trying to think of. Thank you.
What the heck are the blobs made of?
Nickel iron, probably.
Yeah.
They don't just disperse and become part of the whole magma.
Eventually.
So, there's a lot of, don't think of things that as you're used to on the surface of the Earth, where things are liquid, solid, or vapor. In the Earth, there's a lot of plasticity. There's a lot of things that are hot and they'll flow, but they're technically not liquid and they're not melted, but they flow under pressure. So there's a lot of strange materials and common materials that have strange properties. For example, on Jupiter, the pressure there and the amount of hydrogen has led people to speculate and mathematically speculate that there is superconducting metallic hydrogen at the core of Jupiter. But you don't really know. There may be contaminants that poison that effect, but certainly under ideal conditions, the environment is consistent with that kind of material. They're trying to figure out in geology classes and geophysics, they're trying to figure out what common materials on the Earth that we know are in there, how they act under extreme pressure. And they're trying to find, among other things, they're trying to find the moving charge mass that creates our magnetic field. So it's not just like there's a big band of metal down there that's got electrical current running through it. There's some material that's flowing in a what is that?
Well, it says the stuff that's rotating, this moving charge that creates a magnetic field, has got to be orthogonal to basically Greenland, where our magnetic North Pole is.
Well, it's heading for Siberia now. So,
all right, well, but it's
I know
magnetic field is orthogonal to the rotational current.
Right.
So rotational charge, which makes a current.
Yeah.
But it's not uniform, even
so.
Yeah, you're made up of a lot of little currents, apparently, like we are in ferromagnets, all the little atoms that produce a little bit of the ferromagnetism, but the permanent magnetism is the net result of all of that. And that's what we have in the Earth, is a bunch of dynamos. Yeah, exactly right.
Is there a South Pole that would be on Antarctica?
Roughly.
The magnetic I'm talking about.
Yeah, South Pole. Yeah.
Are the poles symmetric about the core?
I don't know the answer to that.
I don't think they're exactly that way, but yeah, they're close.
So there was a planet, I assume it was, called Theia, that became our moon.
Yeah.
Protoplanet.
No, it did not become our moon.
Well, part of it and part of us.
Yeah.
Reconvened and conglomerated and
it turned a major portion of the Earth and probably all of Theia into liquid and sprayed it into space.
It's a good thing we didn't have animals on the planet at that time. That would have been a bad day.
We don't know we didn't, but we didn't have them afterwards.
I think some people have theorized that the collision was the Pacific Ocean.
Yes, right.
I have no idea.
Yeah.
There were probably no continents on it. Well, I don't know that either. No, forget it.
Yeah. And it probably vaporized just about everything.
Yeah. Yeah, the insurance rates on property afterwards would be astronomical.
Yeah.
That's something we never see in astronomy, is it? Is actual bodies that size colliding anywhere.
Well, we saw some big comets colliding with Jupiter. We see.
Yeah, I know you brought that up. That's
Shoemaker-Levy, yeah.
What did it on the other side, out of sight of the collision? We just saw the black splotches when it came around.
Yeah, but there was a spacecraft there, Galileo, that saw the explosions.
Ooh.
Saw some of them.
There were two asteroids that collided.
Oh, really?
And I would have to look up on Wikipedia when and where it was, but it was within the last 50 years, I think.
Yeah, and we see stuff hit the moon all the time.
Yes.
Really?
Yeah. Amateurs tend to take videos of the moon, and all of a sudden there's a white spike. And then they look later and there's a new crater. Teeny tiny, but new. You can't see it from Earth. You get it from an orbiter.
Not going to get any new Mares, though.
Yeah. No new Mars.
Hopefully not. We've used up the big stuff.
Yeah. Uh-oh.
The albedo of the moon is only about 16%, right?
Yeah, the moon is very dark, actually.
Yeah, so if something hits it, you can see the white spot.
Yeah. Any new stuff, because the proton bombardment ages the moon's surface to be dark.
But all that dust that was on Neil Armstrong's boots, that's from collisions only, right? That's the only thing that makes dust on the moon.
Yes, and it there might be volcanism, because the Chinese examined returned samples, I think, and they saw glass spherules in it, which are produced from melting things, cooling and becoming a sphere, but it could also be from volcanism. So, but most of the moon dust is real jagged and is abrasive. And I've heard it smells like spent gunpowder.
Do you suppose there'll be highlands they can land on where they're just walking around on rock, just bare rock, like climbing the hills around here?
Time will tell.
Okay.
So
The moon
this
dust also stuck to everything,
the what?
from electrostatics.
Well, that's the dust we were talking about. I'm
Yeah,
thinking
right.
something like granite, canyons and mountaintops and
Yeah.
Hey,
Yeah, but
Jerry?
there's no real wind or erosion on the moon other than things hitting it. So there's probably some dust most places.
Hey, Jerry, in this equation, that big E shaped thing, is that a summation?
Yes.
Summation,
This
Greek
thing
letter
here,
sigma.
yeah, it's a capital sigma, and it means you sum these terms. It's a shorthand notation for summing all these terms with changing the index. So the first term actually is summed here for us, and it's 1. And this is the gravitational potential at distance r from the center of a mass m, and this is the universal gravitation constant. So just 1 is an approximation of the Earth as a sphere. Now, it turns out in order to approximate the Earth accurately for spacecraft, you don't need, this is general, you don't need all these terms because a lot of them are vanishingly small. You only need n equals 3 and n equals 11. So the Earth is like a sphere with a pear-shaped lobes on it and then 11 gear teeth around the outside. And that's the way that we model orbits.
you know who came up with this formula?
What's that?
Who came up with this formula?
This is what's called this is an expansion of a function in polynomials. And the polynomials that are used are associated Legendre polynomials.
Okay.
And those are, if you take a sphere and you hit it somewhere, it will ring and it will pulse in and out in a different pattern of nodes and antinodes. And each of those basic patterns is one of these terms.
And did I miss the V? Is that volume?
No, V is gravitational potential.
Oh. Okay, what's GM?
G is the universal gravitational constant. This is the mass of the Earth. And this is the radius from the center of the Earth that this V has that potential value. And if you take just the first term, that's an assumption that the Earth is a sphere. If you take the second term, actually the third term, and forget the second term, so this is n equals 3, and you go through all these are easy, these are just trigonometric functions. This is the Legendre polynomial, but that would be the pear-shaped pattern, just n equals 3. So it has 3 nodes and antinodes between them. And then the 11th one has a minor contributions, and all the rest of these terms are there, but they're all so small you don't need to worry about them.
There's no way to modernize this and take out those epsilons and reinsert something.
This is the modernized short form.
Epsilon, huh?
It's not epsilon, Ron. That's sigma. That was what Tim just asked about.
Yeah.
Oh, that's right. I'm sorry.
Yeah.
Looks like an E, right?
And if the parts become, and if these terms, the difference between these terms becomes very small, then this epsilon becomes an integral sign, and you integrate over it instead of sum over it. But that's another story.
Well, I've written it down on my hand so I can have it with me in the test.
Okay.
Whee!
So as a bonus,
Yep.
this is JunoCam, which
Little Io.
What's that?
Little Io, the upstart, the one that's the brat
Yes.
of the moons, just won't
It's the
stay
closest
still.
moon, yeah.
By NASA. This shows between this frame, PJ64 and PJ65, you can see
68.
what's that?
It's
68.
Oh,
Yeah.
68, yeah. See, I had no chance of reading that depth. They found a new volcano down here with a new magma flow.
Well, I thought it was covered with volcanoes.
It is covered with volcanoes, but they're not all active at the same time. Every
Oh,
time hot pressure builds up a hot spot, and then all of a sudden the pimple pops.
I thought it was like a round pizza. There's
It
flooded.
does look like that.
Well, I know, but aren't there just fields of lava, hot lava
Yeah,
everywhere?
but it's low temperature lava. It's mostly sulfur compounds.
Right.
And most of
Good
it's
acne.
solid surface, Ron. It's not all liquid.
Really? I just had the feeling. I've heard that it gets wrenched by Jupiter's gravity because it's the innermost moon, right?
Yeah.
It gets massaged by Jupiter's gravity, which creates energy, transfer of energy.
And
yeah,
the other moons contribute quite a bit also.
Yeah.
So we don't have any plans to land on this one, do we?
No, not I don't.
What is the JUICE probe?
Jupiter Icy Moons Explorer.
So it's going to the two icy ones? That would be what, Enceladus? No.
Well, there's many icy ones, but it's going to Enceladus is a moon of Saturn. It's going to Europa and Ganymede.
Ganymede, that's the picture we had at the beginning of the hour. Interesting. New eruption near Crimea.
And Callisto's icy too, but I guess they're not going to spend much time there.
The word Crimea Mons. Mons means mountain on a foreign body, doesn't it?
Yes.
Okay.
We're back to
The closing.
yeah.
In the telescopes the other night, Venus was half phase. So that was really
Yes. As I pointed out in the talking points up here, there's a term for that.
dichotomy. Yes.
Yes, dichotomy. Yes, I didn't know that before finding that. So when the moon is at first quarter, that's a moon dichotomy.
Dichotomy. I thought it meant dichotomy is defined as two sides or two parts to a problem or something. Horns of a dilemma.
Yeah.
Okay. So that's Mars on the bottom.
Oh, that's Venus.
Oh, that's Venus. Oh, got it.
Yeah, I didn't take a look at Venus, but I went to Betelgeuse, and the atmosphere was so there was a lot of upper winds, so it was really a bad scene. But it actually helped with the color.
Yeah.
If you look at Betelgeuse, it was all puffy, but that puffiness really allowed you to see the color there better.
Yeah, if you defocus it too, you get the same effect.
Yeah. I went to the Winter Alberio, same thing, but it was a little bit dim. But it's hard when you get nights like that, Jerry. You just give up on trying to see a planet. It just looked like it. I told people here, well, here's Jupiter, and they went, whoa.
Jello Jupiter.
Yeah, it wasn't very good.
Well, you gentlemen, telescope experts who are at the star party, have an agreement among you not to be next to each other watching the same thing, I would imagine.
No,
right?
we don't have any agreement like that.
No, we used to try to do that. I would hand out a little sheet of paper saying, these are great targets for tonight. Pick one and that's yours. And then the other people would do other ones, but everybody just went to what they like to show. So,
Well, how many did we have set up on Saturday night?
14 telescopes.
And
wow.
Tom Totten was out in front of the greeting table even.
Yeah.
With his. And
313 members of the public.
Dave Larson had the Orion Nebula, and so
a lot of people had Orion Nebula.
I kind of got stuck on Tessa's favorite on the Owl Nebula or Owl Cluster.
Owl Cluster, yeah.
And so I didn't want to, but I had a huge line, and everybody wanted to see it. Don't move it yet,
Yeah.
My favorite was I put a green filter in one of my eyepieces. And I told people that I wanted to take a closer look at the moon to see if it really was made of green cheese. It was like a really emerald green. So
how did the audience react to that?
They actually, it was funny. The kids probably kind of sat there and just kind of went like, huh? But the parents, they actually liked the different view of the moon. It kind of brought out different the features were all the same, but you got a different look at it. So it was kind of interesting. They kind of enjoyed it.
Okay.
Well, on a full moon night like that, would we have had 14 different things to see in the sky, as limited as it was up there?
Yeah, the winter
Sure,
sky
yeah.
is full of stuff.
Well, it was awesome. We had 200 to 300 people, didn't we, Chuck?
313.
313.
Oh, about halfway through the night, I suddenly panicked, realizing I didn't have that little clicker counter thing. Your wife did.
Pat had it, yeah.
Gentlemen, I'm awestruck again. That's it for the Astro Hour number 203. Next Monday, the 204th, we'll meet again on Zoom screen for our big foray into the cosmos on behalf of Santa Barbara's Astrophysics Telescope Club, the Santa Barbara Astronomical Unit. You guys take care of each other. We'll see you Friday night out at Westmont's Telescope.
I'll see you this afternoon, Tom.
Okay,
Thank
thanks.
you, guys.
Thanks,
Next
everybody.
week.
Thank you.